So welcome to today's Conscious Club. As that little note said, the first part of the meeting will be recorded, the presentation, but then we'll stop the recording, and then for the Q&A, that won't be recorded. And we have a slightly longer slot, as many of you know, hour and a half. So we'll have some more time for Q&A after the main presentation. So it's a real pleasure today to have Ian Phillips joining us to give today's talk. So Ian is currently the Bloomberg Distinguished Professor of Philosophy and Brain Sciences at Johns Hopkins, and he holds joint appointments in both philosophy and at the Department of Psychological and Brain Sciences. And prior to this, Ian held professorships in philosophy at Birmingham and St Anne's College, Oxford. And prior to all that, and I only just learned this, in that you did your PhD here at UCL. So it's kind of like a nice synergy there in philosophy here. And as you'll see, Ian's work, it's at the intersection of philosophy of mind and brain sciences. And I've got to know Ian's work through connections to consciousness science. And I find this tremendously exciting because he's that rare breed of philosopher who not only knows the empirical neuroscience and psychology literature extremely well, but also has an incredibly incisive and sharp insight into identifying the most important questions in our field. And so that's, of course, incredibly valuable for all of us here interested in making progress in consciousness science. So we're very grateful for you spending the time with us today, Ian, and the floor is yours to talk about perception, action, and experience.
Thanks so much, Steve. That's a lovely introduction, and it's really wonderful to be here, even if I'm very sad I'm not back in my old stomping ground in London. Okay, so I'm really keen to get everyone's input in this material, so I will probably end up skipping bunches of slides so I can stop and have some discussion. And I hope I can go relatively quickly with this esteemed audience. Okay, so I want to begin with a passage from Andy Clark, in which he gives voice to what he takes to be our kind of naive or intuitive, though ultimately in his view completely false, vision of how our mental lives unfold. So this is what Clark says. He says, our human mental life looks to involve a seamless unfolding of perception, action, and experience, a golden braid in which each element twines intimately with the rest. We see the very world we act in, and we act in the world we see. But more than this, visual experience presents us with the world in a way apt for the control and fine guidance of action. So, I mean, I take it there are kind of three basic ideas in this passage. The first being that all perception is conscious perception, that being the most intimate entwining of perception and experience. The second being something like the thought that all worldly action guidance is perceptual. So, insofar as the world is informing the course of your action in an online manner, it's doing so exclusively through perceptual channels and conscious perceptual channels by the first thought. And finally, everything that you get in perception is available for action guidance. So that's something like a minimal access condition on conscious perceptual experience. So we see the world we act in, and we act in the world we see. And I mean, this will be extremely familiar to the crowd here, but you might think that the last 50 years, if not more, of cognitive science has uncovered kind of repeated and decisive counterexamples to these ideas. So in particular, work in neuropsychology has witnessed striking dissociations, it seems, of action and awareness in conditions like blindsight and neglect. And then psychophysical work, which actually goes back probably to Johns Hopkins in the 1890s, looks to have uncovered extensive evidence of visual processing in the absence of awareness. So as some of you may know, my work over the last 5 or so years has been kind of pushing back on some of these ideas and really raising a dilemma for proponents of unconscious perception. And that dilemma, as I see it, divides over how the absence of awareness is being established in any putative case of unconscious perception. So one way of establishing the absence of awareness is just to ask subjects, so to use, as it were, a subjective measure. And the problem there that I raise is certainly not a new problem. goes under the name of the problem of the criterion in the detection theory literature. And that's really the concern that subjects may underestimate their conscious experience when asked, are you aware of something or do you see something? And just to illustrate that thought with a case that I spent a lot of time thinking about recently, I want to just explain how that problem arises in the context of blind sight. So this is probably the most influential neuropsychological condition in the science and indeed philosophy of consciousness, originally studied by Larry Weisskranz back in the 70s, and in this kind of monumental third edition of his book, Blind Sight, kind of reviews a huge amount of literature. And as I'm sure you all know, blind sight's a condition that's caused by destruction of primary visual cortex. So here you see two scans, one of the most studied patient GY, and you can see very extensive damage of his left visual cortex. And also an extremely interesting patient, TN, who suffered 2 strokes about a month apart and leading to bilateral destruction of both primary visual cortices and indeed extensive other regions too. And due to the way that the primate visual system is organized, those lesions lead to visual defects in the contralateral visual field. So GY's left hemisphere lesion leads to deficits with visual perception on the right-hand side of space. Okay, so given their damage, these patients, it's really not surprising that they report being blind in the corresponding areas of their visual field. And here you can see a kind of classic presentation of perimetry, establishing that in the clinic in patient GY. So he's just being asked whether he can see a bright white stimulus flashed at various regions in his right visual field. And there are a few white circles in the middle in his fovea. And actually those correspond to a little bit of spared cortex at his occipital pole. But for the vast majority of locations, those black radii correspond to collections of cases where he's been presented with a stimulus and he said, no, I can't see anything. So it looks like he's blind. But of course, blind sight is not simply blindness, otherwise we wouldn't be interested in it. Subjects like GY have been shown to exhibit a wide range of preserved visual functions, including motion discrimination most saliently, but also discrimination of orientation and simple shape, discriminations, e.g. in patient DB between squares X's and O's, emotional facial expressions in effective blind sight, and detection of high contrast stimuli. And this is work with GY again. And I mean, you all have, I imagine, have seen this this video, but here's TN closely shadowed by Larry Weisskranz there in the background. And remember, TN has bilateral lesions, so complete blind sight. So he's walking down this corridor, navigating these obstacles that have been placed in his way, saying he has no idea how he does it because he can't see anything. But you might look at this and think, well, if you can navigate this successfully without conscious awareness, then why do we need conscious awareness at all? And that's indeed a thought that many people have had in relation to these kinds of cases. Okay, so as I say, hugely influential, here's Weisskranz writing in retrospect of how the phenomenon of successful performance without awareness across a startlingly broad range of visual tasks just must have a bearing on the neural and philosophical aspects of consciousness. And writing of Weisskranz's work, here's the philosopher Pat Churchland talking of how the revolutionary blind sight results just knocked the stuffing out of the obvious assumption that awareness of a signal is necessary for an intentional response to that signal. And I take it that's just part of the golden braid conception, that conscious perceptual awareness of a signal is what you need to act in relation to the world. Okay, so does blind sight undermine the golden braid conception? Well, I think there's an alternative hypothesis which really needs taking very seriously here, which relates to this problem with the criterion. So the issue arises here because the tasks which are used to assess awareness in blind sight are effectively questions like, did you see anything on that trial or not? Or did you have any conscious experience on that trial or not? And those are questions that are subject to conservative response bias. So maybe GY is saying no, or pressing the no key in this perimetry study, not because there's absolutely no conscious experience at all, but because he's not really sure whether he saw something or whether it was very degraded or it was kind of weird, or a whole host of reasons that might go into producing that negative response over and above the brute fact of whether there's awareness or not. But in contrast to that, the tasks which are being used to assess residual sight in blind sight are typically forced choice tasks or forced response tasks, and those are effectively bias-free. So, I mean, I told you earlier, for example, that GY can do simple detection tasks in his blind field, but typically those tasks have the following form. You present a stimulus in one of two intervals, so either, say, in the first or the second of two temporal intervals, and then you say, in which of those intervals was the stimulus presented? And he might say, I mean, he's now a very practiced patient, and so this is really not the sort of thing, I suppose, that he's likely to say at this point, but a very natural thing for him to think is, I didn't see anything in either interval, so how on earth can I do this task? But that isn't an option. He has to choose one of these intervals. So it might be that each individual taken individually is such that the stimulus falls below his conservative response threshold, but when he's forced to choose between them, he just picks whichever produced the highest signal. And whilst that pattern doesn't establish the following thought, it's completely consistent with the following thought, which is that blind sight may be severely, and it is severely degraded, and also qualitatively shifted, conscious vision, which is being unreported by the subject because they have a distinctively conservative response criterion. And I've added there in unstable because part of the picture also requires an instability and criterion to explain. Okay, and so I don't want to give a talk on blind sight, but I just want to flag three small reasons why you might be inclined to take this picture seriously, and then just advertise some work of mine before moving on. So one reason to take this picture seriously is that if blind sight is a matter of a conservative response criterion, then you ought to expect that the subject to report awareness or report conscious sight even in different circumstances. That criterion is something that's under their, in principle at least, under their control. And there's some evidence of that. So I gave you this perimetry plot from Sterrig and Barth, but they didn't just ask GY the question, do you see anything? They used exactly the same high contrast stimulus in a second block of trials and asked GY the very similar question, but just the question, are you aware of anything? And this is what happens. So suddenly, a large number of locations in the blind field appear to be corresponding to awareness. So this became known as type 2 blind sight. And in ways, one way of hearing what I kind of think of blind sight as involving is that all blind sight is type 2 blind sight. It's kind of residual awareness that is sometimes being unreported. Okay, and another thing that you might do, instead of asking just these binary yes/no questions of the subject, do you see anything or not, you might offer a more nuanced reporting scale. So this is a nice experiment, which I think is a good proof of concept, at least, by Chiara Mazzi and colleagues from 2016. So with a different patient, they gave her a whole bunch of discrimination tasks, like orientation or color discrimination tasks. And in the first block, this is the top one, experiment 1, they just asked her on a trial-by-trial basis, okay, you've made the discrimination, like say left or right. Were you doing that by seeing, or did you just guess? So it was a seen guessed response. And what you're seeing at the top here is, in black in these bars, are the number of cases where the black represents just guessed. So you can see that apart from in the contrast discrimination, the woman is indicating that her discriminations were basically all guesses. But then with exactly the same stimuli, they offered her in the second experiment a a version of the perceptual awareness scale where she was able to say 0 for absolutely no experience on that trial, 1 for weak experience, 2 for almost clear experience, and 3 for clear experience. And the black here are the zeros. The dark gray here are the 1s for weak experience. And then the slightly lighter gray are the 2s for almost clear experience. And what you can see is that what was black, I didn't see anything in the first, it looks like it's collapsing across weak experience and no experience, whereas the scene is clearly corresponding to almost clear experience. So this is at least some evidence that this subject is not using didn't see it responses to communicate absolutely no experience, but rather to divide her experiences into the ones that are almost clear and above or weak and below. And it's a little hard to interpret this too strongly, but there was no evidence in this study of above chance performance, just looking at the no experience, the black bars. So the only cases where there was any above chance performance was in the cases where she reported absolutely no experience. Lastly, something this is an anecdotal report from a paper with GY, but in a particular block where he was given a very low contrast stimulus, he spontaneously reports to Zeki and Fish that his awareness scores in this block should be -1 or -2. And again, I think that's telling evidence that his 0 is not an absolute 0, right? And if it's possible to be -1 or -2, then 0 is not corresponding straightforwardly to no experience. Okay, a huge amount more to say, but I hope that's sort of a teaser towards the thought that we should take seriously the hypothesis that there's residual awareness in blind sight corresponding to the preserved performance. And if you want much more on the more kind of psychophysical objections and what I think they don't work, then here's an advertisement for a recent paper of mine. Okay, so that was all to talk about how there's a problem with subjective measures. So if you use subjective measures to assess awareness and so claim that a case is unconscious because of the subjective measure, then you face this problem with the criterion. But what if we don't do that? What if we say, well, let's use an objective measure. Let's insist that a stimulus is unconscious only if it's strictly undetectable by the subject. Well, then another problem I think arises, which I call the problem of attribution. So just to illustrate that, think of a completely classic priming study where we present some prime, here, these arrows followed by a mask, and maybe those arrows are such that they're either undetectable or at least that the relevant feature isn't discriminable. So the subject is a chance in saying whether they're left or right. But nonetheless, when we look at response times to that conscious target, they're faster when preceded by a congruent prime. So here I think the problem is that we can understand the effect here just in terms of the prime activating either the visual system or perhaps the visual motor system. And if I want to claim that prime doesn't itself make itself available or its representation to guide action, we can't conclude from the activation of the visual and motor system that the subject themselves have genuinely perceived the stimulus. I mean, so we don't think, and this is a point I think that is shared by both philosophers and psychologists, that any activation of any bit of your brain counts as you perceiving something. Rather, we want to say that genuine perception is by a subject or by an individual. And it takes more than a bit of some subsystem of yours or some part of your brain to be activated for that to occur. So subliminal priming can be understood in terms of the automatic activation of a visual or visual motor subsystem. And if that's all that's been shown, then I don't think we have evidence of unconscious perception. Nothing here conflicts, I think, with the golden braid. Okay, so it's widely agreed that the mark of the individual level, maybe not the mark and maybe not a sufficient condition or even a necessary condition, but like a powerful criterion which provides strong evidential support of a representation being at the individual level, is its availability to directly guide action. And that's why, I mean, that thought there is why that in many of the debates I've had about these issues, in particular with Ned Block, in a bunch of papers and various others, including Bob Kentridge in this paper led by Megan Peters, there's been a strong emphasis on cases where many people have thought that either a patient or a neurotypical subject is acting in some way in the world in a way that's guided by unconscious representations. And this is also really at the heart of critiques by Josh Shepherd and Nita Mopoulos and Jake Berger in these papers. So that's what I want to focus on in the rest of this talk. So I want to talk a bit about visuomotor action in neurotypical subjects and also in patient DF. Okay, and I should say that the thing that I've been tempted to say about most of these cases in the past is that it's not obvious that they really constitute genuine action, the actions in these cases, or at least the modulations of actions in these cases by the individual. And then looking back at some of the classic work in this field in doing this project, I started to become less and less convinced that that was the right thing to say, and more convinced that there was more of a case to be made that actually these actions aren't being guided by unconscious representations after all. Okay, so the classic framework here, again, I'm sure this is something that most of you are very familiar with, is Milner and Goodale's two visual systems hypothesis, which is a kind of canonical way of thinking about how visual signals are processed after reaching primary visual cortex. And so the basic idea is that having reached primary visual cortex, those visual signals are processed along two functionally and anatomically distinct pathways. First, a ventral stream pathway, which Milner and Goodale dub vision for perception, because in their view, it's responsible for the construction of conscious perceptual representations of the world, which subjects can use to recognize, categorize, think about the world. And those are the ones stored in memory. And then second, a dorsal pathway, which Milner and Goodale dub vision for action, and which is claimed to be responsible for online control of visually guided actions like reaching, pointing, grasping, and so on. And crucially, at least for Milner and Goodale, it is claimed that the visual information in that dorsal pathway cannot be accessed consciously, even in principle. So that means that the online guidance of our reaching, pointing, grasping, and so on is unconsciously guided. I won't read out these quotations, but these are just quotations from philosophers indicating the kind of immense impact of this work in philosophy. So both Clark and Brogard strongly endorsing this basic idea and drawing the striking consequence, which is clearly incompatible with the golden braid that Clark articulated at the start. It's not to say that there hasn't been any pushback. So John Schwenkler and Robert Briscoe here have a very nice critical paper from 2015 where they argue that actually there's plenty of evidence that the spatial contents of visual experience, so ventral representations, are used in motor programming. So it's not right to think that it's exclusive preserve of dorsal representations, but even they think there's just a large body of empirical evidence showing that non-conscious sources of vision information influence object-directed bodily actions. So they're not at all abandoning the idea that this work shows there's something wrong about the golden braid thought. Okay, so why think that dorsal vision, or if you like, the representations that guide online motor actions are unconscious? So here's Shepherd and Mylopoulos answering that question, and I think they give the absolutely canonical answer is the same answer that Briscoe and Schwenkler give. Two sources of evidence they point to, and the first is from visual motor pointing tasks. So let me just talk about those to start with. So this is a really old and large body of work, classic work begun, I take it, by Bruce Bridgman in the 80s, and then taken up by researchers like Mel Goodale, but also kind of in its kind of most sophisticated development in the 90s by Marc Généraux, and hugely influential in continuing to be in philosophy, and I'm sure in other areas also. So let me just give two prototypical examples of that kind of classic work. It's an experiment by Goodale and colleagues from 1986. So here subjects are sat in front of a target, and their task is to point to that target as soon as it makes a jump immediately after it makes a jump to the right. So it's going to jump to the 30 to 50 centimeters to the right, and then their task is just to reach out and point to it. In 50% of the trials, as the subject is saccading to the location that the target has jumped to, it's going to jump an extra 10%, so an extra 3 to 5 centimeters during that saccade. And subjects are told just to carry on and point to the final location of the target. But what's striking is that they never notice that extra jump. They just adjust their trajectory completely smoothly, as if there was no additional jump, there's no delay in their behavior at all. And what Goodale and colleagues conclude from this is that we have a clear demonstration here that the neural mechanisms mediating the perception of target position can be dissociated from those mediating visually guided reaching movements. A dissociation, they say, is reminiscent of cortically blind patients, so blind-sighted subjects. Okay, here's another classic study, this time by Casiello and colleagues from Mark Gennaro's lab. So here subjects are sat in front of 3 translucent dowels, and their task is just to, as soon as one of the dowels illuminates, reach out to that dowel to grasp it, and also to say a kind of meaningless word. So that's just to say tar. So the light goes on, you reach out, you say tar. And then in a critical session of the experiment, trials always began with that middle dowel being illuminated. But in a minority of trials, the illumination would shift either left or right as soon as the subject had begun their reaching movement. So as soon as the subject reaches out, the light jumps to 1 or 3, and the subject is told, track that shift, and so adjust your reach. So it now is a reach out to grasp the illuminated dowel, and again say tar to signal your conscious experience of that visual change. So looking at the behavior of subjects in this experiment, Casiello established that the reaction time for the motor correction was very quick. So it only took subjects about 100 milliseconds to adjust their reach. But the delay, the reaction time for their vocal response, that second tar, was much longer. It was like 400 or so milliseconds. And indeed, they say that on some occasions, the dissociation was such that to their own surprise, the subject was already lifting up the second dowel, the one that it's jumped to, while they emitted their vocal response. And they conclude from this that there's this extra 300 milliseconds required for conscious awareness. And the fact that the subject has already adjusted their reach and reached out, maybe even to the dowel, shows that there's a clear dissociation between that awareness and their motor responses. Again, they cite blind sight as a parallel. So this picture from a textbook concludes, as the textbooks conclude about this study, this just shows it's possible to dissociate behavior and awareness. But I think, and this is what I'm really curious to hear, comments on, there's just a simpler explanation of what's going on in these studies, and many like them. And the thought is just that accurate pointing or reaching to a target only requires accurate in-the-moment representation of its location. So you don't care where the target was or where it will be. All you need to do to reach out or point to a target is to know where it is right this moment. On the other hand, to detect a change in the location of a target may, especially in circumstances where that change is being masked by occurring during a saccade or something like that, a whole series of further processes to occur. So you need to encode the original location of the target, maintain that original location, retrieve that original location, and then compare it with its current location. If you don't do all of those things, then you aren't going to be able to determine that a change has occurred. So just to illustrate that, I mean, for those of you who've seen this before, then my apologies. Make yourself a cup of coffee for 30 seconds. But for those of you who haven't, just stare at the next slide for 30 seconds and tell me at the end whether there's anything interesting about it. Okay, for those of you who haven't seen this before, has anyone thought I was doing anything more than wasting your time? Did anyone notice anything interesting about that slide? Okay, so the final slide looked like this. The first slide looked like this. And if you're like me, when you first saw this, you had no idea. Okay. Now, I think the absolute wrong thing to conclude from this is we don't see color. Like, clearly, we were aware of the color of the carousel during the entire thing, or at least I'll defend that conclusion. But many of you did notice the change. So clear dissociation between being able to represent the color of something in the moment and having any awareness or capacity to represent change. Okay, so now I've retrieved for you and, as it were, stored for you the old color and put it alongside the new color. You can do that comparison and retrieval process, but maybe you've completely forgotten what it started out as. Okay, failure to notice change doesn't mean you didn't see color at the same time. Well, similarly, failure to notice a change in location doesn't mean you don't consciously perceive target position, I want to claim. So the fact that the subjects don't notice the jump can't be used as evidence that the location of the target isn't being consciously represented throughout, or at least, largely throughout this this experiment. So I don't see how in this study we've got a clear demonstration that the neural mechanisms mediating the perception of target position are dissociated from visually guided reaching, because we can think of the representations of target position as being conscious and guiding the reaching movements. What's not available, as it were, to the subject here, or they're failing at least to achieve, is an awareness not of position, but of change in position. And I think much the same can be said here. So the course correction reflects the fact that subjects are able to update their representation of target location and adjust their motor response quickly to that. And maybe that takes 100 milliseconds. But the second TAR is doing something else. It's indicating not that they've updated their representation of target location, it's that they've had an experience or judged that there's been a change in the target's position. And again, you might think that requires a series of further processes to occur, the comparison and retrieval and so on. And maybe that just takes longer. So if those additional processes require any time, then that might explain the extra 300 milliseconds. Okay, so again, I don't think we've got evidence here of dissociation. And I mean, there are many studies in this domain, and I'm fascinated to know if there are ones that deal with this objection. But in ways, the question I want to raise about this body of work is why there isn't a simpler explanation of what's going on here. Okay, I was going to talk about dissociations in the visual periphery, or maybe I'll say a quick word about that before moving on. So this is a classic study, although it's not hugely talked about, by Goodale and Murphy from 1997. Here's the conclusion that Ned Block wants to draw from this work. And I'll talk about the study in a second. The conclusion that he wants to draw is that our grip accuracy really is pretty much the same once you've left central vision between 5 degrees and 70 degrees. So constant across much of the visual field. Whereas our conscious perceptual discrimination is vastly worse, much worse at 70 degrees compared to 5 degrees. And this result is supposed, again, to be a dramatic illustration of dissociation between a conscious system underlying our conscious perceptual discriminations and our action guidance system. So let me just talk about what they did in the study. So subjects, this picture is from a more sophisticated replication, which largely replicated these the results I'll talk about from Brown and colleagues in 2005. But subjects were sat in front of a target object, which was an Efron block displayed for 100 milliseconds. And then they were asked to fixate various points along the horizontal meridian from 5 degrees to 70 degrees. So the object was always right in front of their body, but at various different locations in respect of their head-centered frame of reference. And they were given two tasks, either a motor task, which was to just reach out and grasp the block, and then what was measured was their maximum grip aperture during the movement, or a perceptual task where they were to categorize the block using a scale from 1 to 5. So there were 5 blocks, and they were taught which was which. And what they found was that perceptual width estimates decreased with eccentricity. So subjects were increasingly inclined to, as it were, identify the block as a smaller block in increasingly eccentric locations, but maximum grip aperture increased with eccentricity. So although there was a decent scaling at any particular fixation relative to the block size, you can see that maximum grip aperture is increasing as we get towards 70 degrees. So does that represent a dissociation that is an action perception dissociation? Well, I think there's a really kind of clear alternative explanation of what's going on here. And that's just that eccentricity decreases our spatial resolution in conscious vision. And that means that subjects are much less certain as to where the block is located. And as a result of that, use a larger grip size to avoid missing it or colliding with it. And there's a model of this in a paper by Schlicht and Schrater from 2007, which just says we can model this in terms of subjects treating that uncertainty as an effective increase in the size of the target. So it's a very simple linear model, and they basically recover the data quite nicely from it. So the more visual uncertainty, the larger the effective object size, I need to think of myself as gripping, at least as I'm heading towards the target, and so the larger grip aperture. And of course, that presumes that spatial perception is not constant outside the visual field, quite the opposite. So why do Goodale and Murphy, and indeed Bloch and Brogard and various other people, think this is not what's going on? They give two reasons. The first thing they say is that the uncertainty explanation cannot explain the increase in grip aperture, because grip aperture is not any more variable in the far periphery than in the near periphery. So you might be concerned about these very large error bars, but roughly what you're seeing here is that the variability of the maximum grip aperture is not increasing as we're moving into the periphery. And the second thing they say is that they obtained virtually identical results, both in the original and the replication, using just one block. So in a block where the subject knew which block it was, suggesting that uncertainty was not the thing that's causing there to be an increase in maximum grip aperture. Okay, so are these good reasons? Well, the first thing to say is that there are two sources of uncertainty in this experiment. One is uncertainty about which block it is, namely the width uncertainty, but then there's also uncertainty about location, and using the same block doesn't change location uncertainty. So if the dominant source of uncertainty, which is guiding grip aperture, is coming from location, then this wouldn't make any difference, this manipulation. And you might think that if you've been trained with 5 easily discriminable blocks, then there wouldn't be much uncertainty about width, but there would be about. location. And of course, location uncertainty is only going to affect the motor task, not the matching task. But what about this increase in variability? And this is what I'm slightly less sure about. When exactly we should expect increases in variability and when not. So one case where you clearly would expect variability in grip aperture is if the perceptual system was kind of giving wildly erratic estimations of width depending in the periphery. So if on one trial it would seem to you, as it were, that it was very wide, in another trial very narrow, and another trial in between, then you'd expect an increase in variability. But if what's happening is that location uncertainty is driving the effect, then you wouldn't expect any increase in width in the grip aperture to be increasing. You were just moving the variability, as it were, would be in this dimension. Moreover, if, as it were, the strategic response, it's a sort of strategic response to an effective increase in object size, then it's not even clear there that you would get an increase in variability. One other thing to say is that the maximum grip aperture is clearly a kind of snapshot measure of what's going on in action. So it's measuring just one moment roughly midway through the course of your reach. And so you might think that if you're strategically responding to uncertainty about location, then we ought to also look at what happens when you get to the target where the width of the object is going to be more critical. And maybe there we would find variability more at the periphery than in the near periphery, far periphery than in the near periphery. And that's what you do find. So if you look at, this is from Slick and Schrater again, if you look at variance near contact, that does increase with eccentricity. So again, I'm not really sure that this kind of work is evidencing a dissociation, although I think there's definitely more to look at. Okay, let me skip on. So let me just mention one thing about the other main source of evidence for perception action dissociations before I'll stop. So the second thing that here Shepard and Valopoulos, but clearly many others have pointed to, is dissociations in visual form agnosic patient DF and other patients, but DF is by far the most extensively studied. So again, you'll all, I'm sure, be largely familiar with DF, has extensive bilateral damage to her ventral stream due to carbon monoxide poisoning, but her V1 was spared. So she can see some things. So she's got conscious perception of color and texture, but very poor very poor object size, shape, orientation discrimination. So here you can see the difference in her ventral stream responses to scrambled and intact objects as compared to controls. So the control subjects here clearly strongly differential responding to that bed and that bell pepper or chili pepper as compared to that scrambling of the same DF, next to no difference. Okay. So here's the one absolutely classic study, which was done by Nona Goodale in the early 90s. So she's asked to do two things with respect to an oriented slot, either reach out and post the card or the card through it, or in various different studies, different things, but in this one, indicate the orientation of the slot by orienting it at a distance. So here you can see her doing that matching task, indicating the orientation of the slot as she sees it without reaching out. And you can already see that the performance is extremely poor. So let's just do one more trial. So it doesn't look like she's capable of seeing orientation, and that continues. And but here's a trial where she's reaching out to post through the slot. Okay, so on the face of it, very impressive dissociation there. So if you average across trials, you can see that her orientation matching is pretty random, whereas of course control subjects are very good at that task, but her posting is extremely good, nearly as good as control subjects, not quite. And the standard story here, and here's a quotation from Ned Block, but it's very standard, is that what's going on here is that DF's conscious mind, namely her ventral stream, cannot see orientation, but nonetheless the orientation is being perceived unconsciously in an action guiding part of the brain, and that's what explaining the task success. But there is an alternative explanation, and that's that she can't see orientation at all, full stop, and that's what explains the matching failure, but that she's using different information to guide the posting behavior. So this is what you might call an obstacle avoidance strategy, where the idea would be that she's attempting to maximize the relative distances between the card's edge and the slot's edge. And if you can succeed in doing that, then without any orientation information, you will be able to post successfully through the slot. So if you can maximize the relevant distances between the edge, I mean, basically give yourself maximum safety room between the edge and one edge and the other, and one end and the other, then that suffices to succeed in this task. And actually, orientation isn't really necessary or sufficient, because if you do see orientation, you still need to know where the midpoint is to do the task properly. But if you've got information about relative edge distances, then you can do the task without it. So initial evidence for this proposal came in a study from Thomas Schenk's lab, led by Constance Hess. And so what they did, this was just work with neurotypical subjects. They changed the slot aspect ratio so that the safest orientation, the one which maximized the relative distances between edge and slot and card, wasn't in line with the orientation of the slot, but rather its diagonal. And they also used very big cards to kind of maximize the risk of colliding. And what they found was that about 50% of the subjects very clearly adopted an obstacle avoidance strategy and posted along the diagonal. So this says end orientation error, but that just means departure from the slot orientation, and the subjects were very good at posting in this task. And I mean, importantly, they also did a matching task, and there was just no difference between these two groups, as it were, the obstacle avoiders and the possibly orientation posters, in respect of their matching performance. Okay, but this has been kind of criticized by a number of people, in particular Block. Says he finds this criticism weak on 3 grounds. The first is that a task designed to elicit obstacle avoidance in normal subjects just doesn't tell us anything about DF. The second is that when you look at DF, and I showed you videos before, she moves her hand forward unhesitatingly and almost always inserts the card smoothly into the slot and begins to rotate it well in advance of arriving at the slot. And Block takes that to be inconsistent with an obstacle avoidance strategy, I take it. And finally, he argues that orientation perception just would be required to avoid hitting the edge of the slot with the card. Well, I say argue, I mean, actually this is just something he claims, and I have already told you why I think that's not correct. I don't think you need to perceive orientation to do this task. But what about the other 2 criticisms? Well, if you look at the details in the Hess paper, it's clear that their subjects also behaved, even the obstacle avoiders, as it were, in a smooth, unhesitating, and successful manner. And quotes, the final orientation of the card was determined before half of the movement was covered. And they put the card in a quick and uninterrupted movement through the slot. So it's not clear that there's any difference here. Really, the difference is in the information being used rather than these aspects of the behavior. But I do think that the first point is correct. I mean, we can't, generalize too quickly from the first case. But I think there's now a bit of stronger evidence. And so this is a more recent study by the same group. So they make use of the fact that we're better at discriminating cardinal orientations, so horizontals and verticals, than orientations in between. I mean, a finding that you might think is just to do with the fact that we're super familiar with horizontals and verticals in the worlds around us and less familiar with things at 47 degrees. This is called the oblique effect. So any behavior that is being guided by orientation representations ought, you might think, to exhibit an oblique effect. So in particular, matching certainly should, because it's a task we are designed to match an orientation, but so should posting if it's based on the orientation representations, whereas no reason to predict that if it's an obstacle avoidance strategy. So just to prove the concept in this kind of paradigm, here's data from a matching task with a card, very much like what you saw with DF. This is in neurotypical subjects though. And you can see the absolute errors in matching are much lower in the vertical and horizontal cases, the far ends of those two conditions. Okay, open loop just means that the subject can no longer see the target as soon as they've begun the reaching movement, or they've begun the, in this case, the turning movement. So that's why the errors are slightly higher. But what about posting? So no evidence for an oblique effect in posting. What you do see though is some differences. So it looks here that horizontal errors are slightly lower than vertical, and it sort of slightly increases. The reason for that is that subjects were always starting from the same, just past horizontal 100-degree position. So important to correct for that. So and check whether this holds where we have variable starting positions. It's also important to do one other thing, which is to try and address the complaint that maybe the dorsal stream isn't subject to the oblique effect. So you might think, well, maybe orientation just works differently in dorsal stream. So one way you could address that would be to use delayed posting. So on the classic picture in Milner and Goodale, if you introduce a delay between your action, between the visual presentation and the action, then you're going to fall back on ventral stream representations. So let's do both of those things. That's what Hess and colleagues do. Use variable starting positions and introduce a delay between viewing and posting to meet that concern. And again, in the matching case, with those conditions in play, we get an oblique effect, no oblique effect in the posting task. And what this suggests, I think, is that there's reason to doubt that any of us, as it were, neurotypical subjects are posting on the basis of orientation. Certainly, there's reason to think that some other strategy is significantly at work, as that should be like our default hypothesis about what posting involves. And if that's right, then we're in a much stronger position, I think, to generalize, or at least be concerned with an interpretation that just assumes that posting in DF is orientation based. So if in general it's true that subjects use orientation-free obstacle avoidance, then we can't conclude that orientation is being perceived, in an unconscious part of the brain in DF. Okay, so I was going to talk about grasping now, but I think I will stop instead and allow time for discussion. I mean, the main thing I would say about grasping is just that, and this again is drawing on Schenk's work, that a critical difference that occurs in reaching out to an object as opposed to estimating its width like this, is that you get haptic and typically visual feedback when you arrive at an object in a grasp. And that turns out to make a crucial difference to how we should think about the performance differences in the two cases. But I'm happy to talk about that if people are interested, but if not, then that's fine. Okay. So let me just end by saying, I certainly don't think I've defended the golden braid and maybe it's false. I mean, it's very naive and simplified thought, but I do think that there's something compelling and intuitive about this conception of our mental lives, and that we shouldn't give it up too quickly. And not everything naive and intuitive is false. So let me open it up to you to tell me why it is false, but hope I've convinced you at least that it's not so obviously false on the basis of this work. Thank you very much.
Fantastic. Well, thank you so much for the talking, and we should first unmute ourselves and give you a round of applause. Thanks so much.